Right, good morning, boys and girls. We are looking at the grade 12 November 2017 question paper today in this video. We are looking specifically at the questions regarding sequences and series or number patterns, question 2 and 3 from this paper. I'm busy just doing a few videos on the grade 12 term 1 and work, and when we're done with that, we'll move on to the term 2 work during the lockdown in South Africa due to Corona. So please join the channel, and there will be lots of videos available for you to watch that you can use. And also please just subscribe to get the notifications and share with your friends, because this is something that they might find useful as well. Okay, so here is question 2 of the November 2017 paper. Starts with, given the following quadratic number pattern 5, -4, -19, -40, determine the constant second difference of the sequence. Okay, now this is not very difficult at all. We're going to start with 2.1.1. Let me just write the pattern here. We have 5, -4, -19, -40, and then I'm going to take the second term, subtract the first term, so -4 minus 5, which is -9, -19 minus -4, which is -15, and then -21. If I take that, subtract that, and then -15 subtract -9 is -15 plus 9, which is -6. -21 plus 15 is also -6. So the constant second difference here, second difference that they asked, is -6. Okay, 2.1.2. Determine the nth term of the pattern. So I want to determine the general term. Now there's different ways of doing that. The one that I work with, 2a is -6, 3a plus b is -9, and a plus b plus c is 5. If you have a different method and you know how to work out with that method, that's perfectly fine. You can use any method that gives you the correct answer as long as it's mathematical. So I'm going to work out the a, substitute it in there, and then I use this to work out the b. I have -9 plus 9, which is 0, and then a plus b. A is -3 plus b, which is 0, plus c is 5. So the c is 5 plus 3 is 8. So my general term is a n squared plus bn, which is then 0n, not necessary to write that, plus 8. And I just want to sort of double check that I worked correctly. So term 1, -3 times 1 squared plus 8 is going to be 5. Term 2, if I substitute the 2 in there, is going to be -4. Term 3 is going to be -19, and I can see I worked correctly there. Then 2.1.3 is, which term of the pattern will be equal to -25,939. So I'm going to make the Tn that. So I have that equal to my general term. So I'm going to take everything over to this side so that I have a positive, and then -25,939. Subtract the 8. If I jump that over, is going to be -25947 is equal to 0. I just want to see if I make that a positive, if that has a square root. Now what is going on? It doesn't. Oh, I first want to divide by 4. Whoopsie. 9325947. So the 8 divided by 3 is 8649, and I actually want to see if this has a square root, which is 93. Okay, so this can factorize into n minus 93. N plus 93 is 0, So n is 93 or negative 93, but I know n is a positive because it's a term number and that's not applicable. So the 93rd term is going to be that. Okay. Then 2.2.1. The first three terms of an arithmetic sequence are 2k minus 7, k plus 8, 2k minus 1. Calculate the value of the 15th term. Okay, value means I don't want a k there. So I have 2k minus 7, k plus 8, and 2k minus 1. Those are the first three terms. Since they tell me it's arithmetic, I know that term 2 minus term 1 should be equal to term 3 minus term 2, and I can use this to solve for k. So I have k plus 8 minus 2k plus 7, 2k minus 1 minus k minus 8. I'm going to take all of the k's to the side. K minus 2k is minus k. 2k minus k is 1k. Jump it over, become minus k as well. Minus 1 minus 8 is minus 9. 8 plus 7 is 15. Jump it over, becomes negative 15. So minus 2k is minus 9 minus 15, which is minus 24. And then divide by negative 2 both sides. So k is 12. Then this makes this, if I substitute the 12 in there, 2 times 12, 24 minus 7. 2 times 12 minus 7 is 17 is the first term. K is 12 plus 8 is 20 is the second term. And 2k minus 1 is 24 minus 1, 23 is the next term. And I can see this is a pattern that goes plus 3, plus 3, plus 3. So in this question, I want the 15th term. So term 15, for an arithmetic pattern, you can use a plus n minus 1d, which I can see it goes plus 3 plus 3, and then you can just substitute that into your calculator. 17 plus 14, 15 minus 1 is 14 times 3, 59. Okay, so the 15th term is 59, and then 2.2.2 says calculate the sum of the first 30 even terms of the sequence. So I want the first 30 even terms. So 23, 26, 29, 32. So it's going to be that those are the even terms. I don't want the uneven terms. The first 30 even terms. So the even terms are 20, 26, 32, which is also an arithmetic pattern that goes plus 6, plus 6, plus 6 with your first term 20. So I want the sum of an arithmetic pattern. I'm going to just write down the formula quickly for that. This formula is on your formula sheet. And then I want the sum of the first 30 even terms. So I'm going to make my n 30. My a is now going to be 20. 30 minus 1, and my d is going to be 6. I adapted the a and the d to work actually with that number pattern. Okay, and then I can just substitute that into my calculator. 30 over 2 is 15. That's 40. 15 times 40 plus 29 times 6 is going to be 3210. Okay. Alright, so that is question 2 of the 2017 paper. Let's look at question 3. It says, a convergent geometric series consisting of only positive terms has first term a constant ratio r and the nth term tn such that the sum of the terms from the third term to infinity is of tn is a quarter. So they tell me if term 1 and 2 is 2, write down an expression for a in terms of r. Okay, so Right, a convergent geometric series, A, R, and N, such that, okay, the sum of the terms from term 3 to infinity of this series is a quarter, meaning if I take term 3 plus term 4 plus term 5 plus up until infinity, I'm going to get a quarter. All right, term 1 and term 2 is 2. So if I add the term 1 and term 2 here, I can add 2 there as well, because term 1 and term 2 is going to be 2. And write down an expression for A. So this term 1 is A plus AR plus AR to the power of 2 plus up until infinity is going to be 2 and a quarter. This is now the sum to infinity is basically 2 and a quarter. So if I look at the formula, the sum to infinity is A over 1 minus R, and the sum to infinity is 2 and a quarter. Is going to be A over 1 minus R, and if I multiply the 1 minus R on the other side, A is going to be 2 and a quarter times 1 minus R. So write down an expression for A in terms of R. A is, there's an expression in terms of R. You can maybe multiply that in if you wish, but you can leave it like that. That's 3.1, and 3.2 is then calculate the values of A and R. So here I have an equation in terms of A and R, which I can maybe use to help me with a simultaneous equation type thing, but I need another equation in terms of A and R. Let's see, what do we have here? Maybe the fact that term 1 plus term 2, which is A plus AR, is equal to 2. Term 1 and term 2 is 2. That's an equation, and that's an equation, and I can use that. Okay, so in this equation 1, I already have the A alone is that, so I can substitute that in there. I'm just going to write this as an improper fraction. 2 and a quarter, 2 times 4, 8 plus 1 is 9 over 4. The A is this, 9 over 4 times 1 minus R, plus 9 over 4 times 1 minus R, and R is equal to 2. So now I have an expression in just R, which I can solve. So I'm going to multiply out the brackets. This is 9 over 4 minus 9 over 4R. There's 9 over 4R that I must multiply. I'm just going to multiply the 9 over 4 and the R in there. So 9 over 4R times 1, and 9 over 4R times R is 9 over 4R squared. Minus 2 is 0. Jump that over because I see this is quadratic. So I have minus 9 over 4R squared. Minus 9 over 4 plus 9 over 4R will cancel, and I have 9 over 4 minus 2, which is a quarter, I think, because I added the 2 to get the 9 over 4 in the first place. So that is a quarter is 0. Let's just change the signs. 9 over 4R squared minus a quarter, divide with a negative 1, and then this, well, you can factorize 3 over 2R minus a half, 3 over 2R plus a half by difference of squares. So you can factorize this, or you can use the quadratic formula with your A is 9 over 4, the B is 0, and the C is negative a quarter to get the value of R. So this 3 over 2R is a half, or 3 over 2R is negative a half. And then if I simplify this, a half divided by 3 over 2 is a third, and negative of divided by 3 over 2 is going to be negative a third. But in the question, I just want to quickly look here, it says that the series have only positive terms with the first term a. So if there's only positive terms, my r is also definitely going to be positive. Only positive terms, because the r is the thing that I multiply with throughout, and if I have a value times negative times negative times negative something, it's going to produce positive negative terms, where if I have a value times positive is going to keep it positive. So the r is the third, and I had most now the a is 9/4 times 1 minus r, so I can now work out the a is going to be 9/4 times 1 minus the r, which is then a third. A third, and by calculator, 9/4 times 1 minus a third is 3/2. Right, so I have there the a is 3/2. 3.2, they wanted me to calculate the values of a and r. There's my r, there's my a. So I'm done. Okay, and that is the sequences and series question from November 2017.